Good morning friends, welcome back to Parnika tutorials. In the last few videos, I have discussed the strategies in handling the deadlock. Totally we have four strategies. One is the deadlock ignorance. What is deadlock ignorance? Deadlock will happen once in a 2 years or 3 years. So the operating system will just ignore it. Is it clear? Now coming to the deadlock prevention. We have four necessary conditions to have a deadlock. One is mutual exclusion, circular wait, hold and wait, and no preemption. Now, if we disable any one of the necessary condition, then deadlock will not happen. So, in deadlock prevention, we have discussed how can we disable any one of the necessary condition. If we disable any one, whether it is practically possible or not. Coming to the mutual exclusion. To disable that one, we went for the spooling mechanism. Meaning is that if you have a printer, multiple process can be execute on the printer. It can take the printouts, but practically it is not possible. Am I right or wrong? For the circular wait, to disable that one, we have ordered the resource numerically. Is it clear? R1, R2, R3. What is the restriction we have kept is that if a resource is requesting for the a process is requesting for resource R3. Let's take that process P3 is there, has requested the resource R3 and it has been allocated. Now the next request can be either R4 or R5 or R6, but it cannot request R1, R2. This is one restriction. Or another kind of restriction is that, let's take the process P3 has requested for the resource R4 and it has been allocated. Now the request is that, or the restriction is that, it can request for resource R1, resource R2, resource R3, but it cannot request for resource number 5, resource number 6. Is it clear? Any one of this restriction, either this one or this one, if you keep, then we can disable the circular wait, which is practically possible. So this is about the deadlock prevention. Then coming to the deadlock avoidance, we have discussed about the banker's algorithm. The next one is the deadlock detection and recovery. What is the meaning? You will allow the deadlock. In deadlock prevention, what you are doing? You are not allowing the deadlock by disabling any one of the necessary conditions. In deadlock avoidance, while allocating the resource to any process, you are checking whether the system is in safe state or not. If the system goes to the unsafe state, you will not allocate the resource to the process. Is it clear? Are you able to understand? In coming to the deadlock detection, we will allow the deadlock. Let the deadlock happens. Then we will detect there is a deadlock. Then we will recover from the deadlock. Is it clear? So we have two phases. One is the deadlock detection and then deadlock recovery. Now let me discuss how can we detect there is a deadlock. We have already discussed about the resource allocation graph. Is it clear? By looking at the resource allocation graph, we can find whether there is a deadlock or not. In a resource allocation graph, we have two types of vertices. One is the process and another one is the resource. In resource also, we have single instance resource allocation graph. Meaning is that all the resources are single instance. And another one is multiple instance of resource graph. Now if it is a single instance, we will check whether there is a cycle or not. Let me give an example. You have a resource R1, you have a process P1, you have a process P2, and then you have a resource R2. Usually we will represent resource like this. Okay, let me represent the normal way. Okay, now you have resource R1 and resource R2, both are single instance. Now let's take that one instance of resource R1 is allocated to P1, one instance of resource R2 has allocated to the process P2. Now process P1 is requesting for resource R2, process P2 is requesting for resource R1. Now the current availability of the resources are 0 and 0, but process P1 requirement is 0 and 1. It is requesting for the resource R2 and it is not requesting for the resource R1. Now process P2 is requirement is 10, meaning is that it is requesting for one instance of resource R1, but it is not requesting for the resource R2. With 0 availability, you cannot satisfy the requirement of process P1 and process P2. So the system is in not a safe state or unsafe state. Is it clear? Are you able to understand? So there is a cycle. Whenever there is a cycle in single instance resource allocation graph, we can say that there is a deadlock. So like this we will detect. When it comes to the multiple instance resource allocation graph, we will use the banker's algorithm whether there is a deadlock or not. We will check it. Can we, the system is in safe state or not? Is it clear? So we will use those mechanisms to find there is a deadlock or not by looking at the resource allocation graph. So we have discussed about the detection. Now we will discuss about the recovery. Now the recovery is respect to with the resources and with respect to the process. Okay, now let me discuss with respect to the process. Meaning is that we can recover from the deadlock with the help of the process, with the help of the resource. What is that one is? With respect to the process is kill any one process. Kill any one process or kill all the process. Is it clear? Are you able to understand it or not? Either kill any one process or kill all the process to recover from the deadlock. Is it clear? Now coming to the resources. Resources also, we can preempt the resource. Meaning is that, let's take that process P1, in previous example, the availability is 1 and 0, meaning is that it has the one instance of resource R1 and it does not have the resource R2, and it is requesting for the resource R2. Similarly, process P2 availability is 0 1, it does not have the resource R1 but it is has the resource R2, and it is request is also 1 0. Now there is a deadlock because process P1 has resource R1 and requesting for the resource R2. Process P2 is requesting for the resource R1 and it has the resource R2. Now process P1 can complete the task when it has a one instance of resource R1 and one instance of resource R2. Similarly, process P2 can complete its task when it has one instance of resource R1 and one instance of resource R2. Now both the process are waiting for other process to release the resources, so that leads to a deadlock. So now what is meant by no preemption? You cannot, the CPU cannot preempt the resources from the process. Is it clear? But when it comes to the preemption, if we use the strategy called preempt the resources, meaning is that the CPU is forcefully taking the resource R1 from the process P1. Is it clear? If let's take the process P1 was preempted, then what will be the current availability? Current availability will be 1 0. Am I right or wrong? Previous the availability is 0 0. We don't have either resource R1 or resource R2. Let's take that CPU has forcefully preempted the process P1. Then whenever the process P1 was preempted the resource, then the resource will be current availability. So with this availability we can allocate the resources to the process P2, then process P2 will complete the task. So like this we can recover from the deadlock. So one strategy is preempt the resources. Is it clear? Are you able to understand? Another one is that rollback. Is it clear? Let's consider that at particular instance there is not a safe state, meaning is that with the current availability of the resources you are not able to allocate the resource to any one process. But in previous stage, let's take that you have stage 1. In stage 1 you found the system isn't safe, in stage 2 you found the system is safe, and stage 3 the system is safe, and stage 4 is also system is safe. At stage 5 you found that system is not in safe state. Then what you will do? You will roll back, you will go back to the stage 4 to recover from the deadlock. Is it clear? Are you able to understand? So this is the strategies you will follow for deadlock detection and deadlock recovery. If you still have any doubts related to this concept, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. Thank you for watching the complete video. Have a nice day.